everyone, welcome to Opportunity X. Today we'll be doing the rain stick experiment. I'm Sabrina, the lead volunteer for this experiment, and I'm a rising junior at the Harker School. And Renee, a rising sophomore at the El Cerrito High School, designed this presentation. So before we get to the actual experiment, there are a few basic concepts that we need to learn first, including the idea of sound waves. So all the sounds that you hear, like your own voice, any pots and pans banging from the kitchen, these are all different types of sounds. And all of these sounds originate as a vibration. And then the reason you're able to hear all these sounds is that the vibration hits nearby molecules, which then hit more nearby molecules, and so on and so on. And then once the molecules reach your ear, that's how you're able to hear. This is called a ripple effect, which you may have seen before in real life. For example, if you drop a rock into a pond, you'll notice that they start off as small waves right next to the rock, but then they travel outwards and form more waves, like a ripple. So the same idea is here in sound waves. And that's how sounds can travel very far distances to your ear. And on the right of the slide, we have two pictures of sound waves. As you can see, a sound wave is essentially just a bunch of dips and high points and repeat over and over and over again. And the sound wave on the left is shorter and the sound wave on the right is taller. And amplitude is measuring this height of the sound wave. So the left one has a smaller amplitude and the right one has a bigger amplitude. Amplitude is also the volume or how loud a sound is. So the left sound wave will be quieter than the right sound wave. Here are two more very important components of a sound wave: frequency and wavelength. So frequency is how fast the sound wave is oscillating or swaying. Again, we have two pictures of two different sound waves on the right. The left one looks more spread apart, and the right one is much closer together, it's crowded. So the right one has a higher frequency because the sound wave is oscillating faster. Frequency is also related to the pitch of a sound. So higher frequency means higher pitch, lower frequency means lower pitch. In the picture, we also have wavelength, which is essentially just how spread apart these sound waves are. The left one is much more spread apart, so it would have a longer wavelength, while the right one has a shorter wavelength. And obviously, frequency and wavelength are related to each other. They are inversely related, which means if a sound wave has a high frequency, it must have a short wavelength. And if a sound wave has a low frequency, it will have a long wavelength. And like I said earlier, frequency is related to pitch. If it is a higher frequency, it'll have a higher pitch. Here I have two questions in a quick quiz. The first one is, what does the amplitude of a sound wave describe? And the second one is, if a sound wave has high frequency, will it also have a large or a long wavelength? And you can pause the video right here and play again when you're ready to discuss the questions. All right, the first question, what does the amplitude of a sound wave describe? Amplitude is how tall a sound wave is. It is the height of the sound wave, and it is related to how loud a sound is. If a sound wave has a bigger amplitude, if it is taller, it will be louder and have a bigger volume. If the amplitude is very short, it will have a small volume. It will be very quiet. And the second question, if a sound wave has high frequency, will it also have a large wavelength? No. Remember, frequency and wavelength are inversely related. If a sound wave has a high frequency, it will actually have a short wavelength. And now we can move on to the actual experiment. Here are the materials that you're going to need. First, you're going to need some cardboard tubes that are about 2 to 3 inches in diameter. For this, you could use some old paper rolls, like toilet paper rolls, the cardboard tube from there, and they just have to be the same diameter. And if you have to, you might have to tape some tubes together so that they form a long tube about 3 feet, at least 3 feet in length. You're going to need 50 1-inch metal nails. You'll need some masking tape, 2 index cards, a few handfuls of rice or beans, and you also need some markers and a pair of scissors. And the procedure for this experiment is actually very simple. So the first step is, if you have multiple tubes that you're going to tape together, you're going to use your masking tape and tape those. If you have a long tube like I'm using, then you can skip this step. And then you're going to use your marker to draw dots around the entire tube, so all the way from the top to the bottom. And since you have 50 nails, you can estimate how far apart your nails should be, but they should be about ½ inch apart. And then once you have all your dots drawn across your tube, you're going to use your nails and poke them through. Be careful with this since the nails are very sharp. Make sure your fingers are out of the way when you're poking them in. And then if there are any nails sticking out, you can use masking tape to cover them and secure them in place. Then you're going to use your marker again and trace around the tube onto an index card so that you have a circle that is the size of the tube, and you can cut those out. And you will tape one circle onto one end of the tube. So you're closing off one end. Do not close off the other end yet, because you need to fill up your tube with your rice and beans. So get those rice and beans and pour them into the tube. And once they're in, you can use your tape and your other cut out index card circle and tape it onto the other end of the tube. And that's it. You can slowly tilt and play around with your tube, listen to the sounds it makes, and just have fun with it. And here's an example of what the inside of your tube would look like. You see these are the nails, and they're poking through the cardboard tube. And once you're done playing around with your rain stick, we're going to discuss some other concepts for the experiment. So here I have a few questions that you can think about. What didn't go according to plan in your experiment? And were the sounds you were hearing low or high pitched, or was it a combination between low or high pitch? And we have a few more final concepts that are a little bit more advanced and are related to the experiment that we're going to discuss right now. First is the idea of reverberation. So reverberation is how sound bounces off of different materials, and it has an opposite, and the opposite is absorption, where sounds are absorbed by different materials. And the important thing to know is that harder materials will reverberate more and absorb less. So for example, if you have a really hard table, there will be more reverberation, which means that the sound will bounce off more. But if you're looking at a carpet, for example, it'll reverberate less and it'll absorb more. So the sound does not bounce off as much. We also have different types of energy that we can study in this experiment. So the first form of energy is potential energy. Potential energy is related to gravity, and it occurs when you have an object that is at some sort of height. When the object is at a higher height, it will have more potential energy. And this occurs in the experiment in the rice and beans when they're still at the top of the tube. So you can imagine right after you turn the stick, they're about to start falling, just at that instant when they're all at the top of the tube. That's when they hold a lot of potential energy. And then the second form of energy that occurs is kinetic energy. Kinetic energy occurs when you have an object that is in motion. So when the rice and beans begin to fall and they're traveling down the rain stick, they have a lot of kinetic energy. So the potential energy that first occurred when they're at this height is converted into kinetic energy when they travel. And the last energy is sound energy, which is energy that creates sound. So when there are collisions between either the rice and the beans or the nails, the kinetic energy is converted into sound energy. And that's why you're able to hear all those cool noises. And the important thing to know here is the theory of conservation of energy. It essentially says that energy cannot be created or destroyed. However, it can change form. So in this experiment, there's potential energy that is conserved but transformed into kinetic energy, which is then transformed into sound energy. I have one more quick quiz with 2 questions. The first one is, do harder materials reverberate more? And the second one is, what is potential energy related to? So again, you can pause the video here and move on when you're ready to discuss the questions. For the first question, do harder materials reverberate more? The answer is yes. Harder materials do not absorb as much sound, and the reason is actually because there is less contact between the sound waves that are hitting the material and the molecules on the surface. So if you're looking at a hard table, which is a very hard material, when the sound wave hits it, it kind of just bounces off because it just barely hits the surface of the material. But if you think of a carpet, a carpet is very soft. So when a sound wave hits it, it'll kind of mush in the carpet a bit, it'll dip in into all the little crevices, and then that's why sound is absorbed more. And for the second question, what is potential energy related to? It's related to gravity. So when an object is higher up, it will have more potential energy. So when your beans and your rice are at the top of the tube, they will have more potential energy. All right, that's the end of the rain stick experiment. I hope you all learned something new today, and I hope you had fun. And thank you for being a part of Opportunity X.